Okay, well, welcome to this meeting. This is the second virtual meeting of the East Midlands Regional Group of the Geological Society. A big welcome, and we're very fortunate today to have as a speaker a colleague of mine from the British Geological Survey, Ben Wood. And Ben actually joined BGS shortly after I did, and we actually worked quite closely together at one point because he was involved in a database on graptolite fossils. In a sort of previous existence, I used to work on Silurian graptolites, Ordovician and Silurian graptolites, and Ben helped and put together a database to help refine zonations. So Ben then left, but then decided BGS was actually the right place to be, came back, and he's basically one of our key software developers. And the last few years, he's been heavily involved in Groundhog, our modeling package. And I'm particularly interested because as the person responsible for all the physical samples at BGS, a lot of boreholes, Ben's Groundhog is a brilliant way actually of visualizing some of the holdings that we've got. So I now want to hand over to Ben. So Ben, would you like to start your presentation?
Yep, thanks, Mike. So as Mike said, I've been at BGS for quite a long time. I originally joined as a web application developer, but I do have a background in geoscience. I have an undergraduate degree from Liverpool in combined physical geography and geology. And then after that, I went on to do a master's degree in computing and earth sciences at Keele University. So I've got a little bit of a foot in both camps. So what I'm going to do today is going to take the form mostly of a live demonstration of the Groundhog software. So for that, I will share my screen. So I will just give a little bit of a brief introduction to what Groundhog is, where it came from, a bit of the history of it, how you can access it. So Groundhog is BGS built software, and the idea is it's a general purpose piece of software for doing geological investigations. Site investigation data can be brought in. We can deal with maps, we can deal with boreholes, cross sections, and also we're now going a little bit in the direction of 3D modeling. So in a previous sort of incarnation, I worked on a piece of software called GSI 3D with a team at the BGS and collaborators, the software owners over in Germany. We've since sort of moved on from that and built this in-house application called Groundhog. So it's entirely built within BGS, and what we're trying to do now is to get it out there and get people using it. So here on the screen is just a little bit of information on where to access the software. And I should also make note of we're actually collaborating with a company called Land Quality Management, or LQM, which some of you may be familiar with. It's a company based out of Nottingham as well. And they're helping us with a commercial version of the software. They're helping us make it sort of fit for market and commercially viable. After the talk, have a look on, we've got a LinkedIn channel where we post updates on the software and information about what we're working on. So please follow us if you can on LinkedIn. It's easiest just to Google Groundhog LinkedIn software. And we also have a YouTube channel as well, where we're slowly building up tutorials and the like for people to refer to. So without further ado, I will bring up the software. So actually, before I do that, I'll just quickly show you the download page. So actually, if you go to bgs.ac.uk/groundhog, we'll resolve to the download page, and that will give you a little form where you just put in a few details, who you are, which sector you're from, sign up to check the privacy policy, etc. If you submit that, that will then take you to a download link for the software itself, the installer. Currently only works on Windows, but it's free to use. in that version. We do have two versions. The free version is called Groundhog Community version, and the commercial one is called Groundhog Professional. The difference being, and we'll get onto this a little later in the presentation, you get most of it for free and you can use it for any purpose whatsoever, including academic research, commercial applications, whatever. But the professional edition comes with some 3D modeling and some what we're calling conceptual site modeling tools, which we're working up with collaboration with Land Quality Management. So I will just kick off with the live demo. So if you install Groundhog and fire it up, you get this basic user interface. Down the left-hand side is where all of your data will appear, and we'll load some data up in a minute. You might see a very slightly different flavor of this depending which version you're on and whether you're in community mode or professional mode. I'm currently running in professional mode at the moment. It comes preloaded with a library of what we call drawing codes or legend codes, but this is fully customizable, so you can create your own codes and color schemes. You can also, if you refer to the manual, it will show you also how to embed your own ornament files, hashing patterns and things like that. And also under here, I'll skip over this time element, that's a little bit specialist, but under here there's also a help tab which will link out, for example, to the YouTube channel. This is a really good resource because it's got some key videos on getting started and some of the specifics, as well as a 50-minute webinar we did as an intro to Groundhog, which shows you all the basics to refer back to, and also one on the 3D model building. So just to make you aware that's there. Okay, so the main user interface gives you blank panels that you can fill up with things like map windows, borehole log windows, and cross sections, basically. So let's get going. So I can create a new map window. So everything in Groundhog is based on the concept of layers. And what we've tried to do is to mimic a little bit the way a GIS system works, so that it's somewhat familiar to people who've used a GIS before. But the idea behind Groundhog, it's a bit like a simple GIS, but with the subsurface added for geological studies. Down the left-hand side, you get various data layers and default layers. And down the right-hand side, you'll see we've also packaged a load of the BGS web map services, and we'll see those in action in a few minutes. So you don't have to add layers straight away. You can bring up a blank map, but if you're working in Great Britain, as I'm guessing most of you are, you should get this embedded topographic base map, which is just an open data layer. Accidentally switched on some geology there. So you get an open data layer, which is coming from actually, it's an Ordnance Survey data set from their open layers, but it's actually being served by an Esri third-party web service. So that streams in. As I said, everything's layers, and you get control, so you can control transparency, and we'll see how the layer ordering works when we've got a few more things in there. The map panel can just be panned around, dragged around as per Google Maps or a GIS system. Just click and drag. And then you can use the mouse wheel to scroll in and out. And there are also fixed zoom in and out buttons here. So that helps you to get your bearings. Before we go actually into doing some geology, I'm just going to load up some kind of contextual information to show you the sorts of data that you can load for yourself. Because the idea with Groundhog Desktop is it's a tool that generally you put your own data in. So we've added these base maps as a convenience, and we've added the BGS maps because obviously they're very useful. And we'll see some stuff to do with boreholes in a bit as well. But the general idea is if you're doing a study or a model or a site investigation, that you would generally bring your own data in for that site. So I'm just going to mimic that here. So I've got some data which I used previously on a webinar a few weeks ago that we ran. I'm just going to reuse that. So I'm going to be working mostly in an area, I think up around Edinburgh, because I've got a few bits of data there. So what I've done is I've assembled a regional topographic map from a GIS, with a world file. So those of you familiar with GIS should be able to produce those easily from QGIS or ARC. And then just to show different layers can come in, I've got this clipped tile of OpenStreetMap as well for the same area. So there's a couple of ways to get data into Groundhog. For certain data types, the easiest way is just to literally drag it into the user interface, and then that will load into this data tree. So you can see here this OpenStreetMap image is now loaded up into the session. Or you can go via the main menu here, and under the main menu there's lots of different options. We'll explore a few of these in a few minutes, but the import one is the place to go to get started. So you can also import images, for example, from there. And that will, in a moment, there's a slight delay on my computer, but it should open up a file chooser dialog, he says. Taking its time. Yep, there we go. So I'm going to bring in, I've actually got, I think, yes, an aerial image. Let's bring that one in. So all these have got world files, by the way, as we'll see in a moment. So I've just got this aerial photograph. So what Groundhog doesn't do straight away is to display the data you bring in, because it's not sure at that point what you want to do with it. So it relies on you to add that manually to whichever scene you want to add it to. So I'm just going to expand the map window a little bit. And then I'm going to add those two images as layers. So there's an add layers button on the map control, and it brings up this dialog again. And you can see now that we've got these two additional entries for those two files that I brought in. So I'm going to hold Controls, multiple select, and bring those in. So let's zoom into where I know that those data layers are. If I switch off the topographic basemap web service for a moment, you can now see that we've got these layers added. If I make the top layer completely opaque, it obscures everything underneath. So if I want to just rearrange, I can just drag those layers up and down in the list and play with the transparency to compare layers. And I also have something called a slider tool. If I toggle a particular layer into the slider layer and then click on the slider tool, I can also use that to compare two layers rapidly. So that might be useful for comparing historic maps, for example, or in this case, aerial imagery with a base map or geology or something. Obviously, you won't remember all of these buttons as we go through, but as Mike's recording it, you can also refer back. And as I said, the user guide actually is online, but also it's embedded within the software under the help menu. There's a PDF accessible. But actually, if you just Google Groundhog Desktop documentation, you'll find that online as well. So we can bring our own images in from a GIS system or wherever we've compiled those. You can actually georegister kind of within Groundhog. So I'll just show that quickly on this aerial photograph. So we have the concept within Groundhog of the active layer in all the windows. If you single click a layer, you can see that its entry in the control panel turns orange, or some people appears yellow, depending on your eyesight, but you can see that it's active there. And when it's active, you actually, depending on the layer, you get different controls, but you can see here I can actually resize this and I can move it around. So you can actually approximately georeference or georegister your own images if you need to. Okay, the next thing I'm going to do is show you some of the BGS data layers that we can put into the map, and then we'll have a look at boreholes after that. So again, if I click Add Layers, by default, when you install Groundhog, it comes pre-configured with all of these BGS web map services down the right-hand side. Some of the names of these are a little bit long-winded, and you might have to just scroll through to find what you need. But let's, for example, put the superficial 1 to 50,000 deposits map on there. that appears. Any layer you add always jumps to the top of the stack. So if you want to push it underneath, you can just drag it around to arrange it however you want it. You can just check on any layers on and off that you do or don't want. And then in the case of the Geology Web Map services, if we make this layer active, let's give it a bit more opacity. If I just, with the layer active, if I click anywhere in the map, it will actually do an identify down in this bottom right-hand corner. So you'll be able to get the attributes from that particular shape from the Web Map service, which is quite useful. Couple of other examples of BGS data layers that you can add in. So we have the boreholes data set. So again, you might have to scroll through and just sort of read through these. But from our GeoIndex system, we have this borehole records, which will appear with all of the borehole IDs as a map. These are, just to be clear, these aren't data sets embedded within GroundHog. This is calling on a web service, a web map service, and displaying an image. And as you pan around, it will do this everywhere in the country for you automatically. We can query the borehole layer as well. I'm just going to switch off the geology map. Every layer you add adds a little bit of performance penalty, by the way. So if you load the map up with lots of layers, it will start to slow down. Let's query a few of these boreholes. So we can use identify on the borehole layer as well. So if I single click the borehole records layer, let's increase the opacity. If I single click that, you can see it's gone orange, which means it's the active layer. And then I can just click on any one of the locations on the borehole layer, and it will give me the metadata from the shape table for that particular location. And I've got a couple of extra special tools here in this identify panel. So one of them is that I can actually create a borehole object at that location, should I wish to. So if I wanted to, say, code up the borehole for my project, I could create a record at that location using the metadata. And I can also click this button where I can view a scan of the borehole log. So this links out to the BGS scans application. I happen to have picked one that isn't available. Maybe that's got some confidentiality on it. Let's try another one at random. So click another record. So if we click this little borehole stick, okay, I'm not doing very well. So what you should be seeing here is the borehole scans application, which many of you may be familiar with. That shows the scan of the original driller's log. Looks like there might be an issue with that system on the website right now. Yeah, looks like that's down. That's a shame. So normally this will give you a PDF view of that driller's log. Let's just try one more in a slightly different area, just in case we're into some kind of confidential data set or something. Let's just try this one. Just thinking about it. There we go. So I think that might have just been a temporary glitch on the BGS website. So you can explore the entire borehole data set of BGS in this way and click through to see the driller's logs as scanned as PDFs, and they're all paginated, so you can step through them, see all of the information. Some of them include things like site plans and so on, as you're probably already aware from looking at BGS data. So that lets you explore our borehole data records. But you can also bring in your own data. So that's what I'm going to show next. So I've pre-cooked a little bit of data in what's known as the AGS data format, which again, I'm guessing some of you will be familiar with. So the AGS standard is a kind of UK industry standard for transfer of site investigation data around geotechnical and geoenvironmental borehole positions. And I've got, I think, an example lurking in here somewhere. Let's get my eye in. Thought I had. Yes, so I have an AGS file here. Let's just have a look at that in a text editor. So if you have your data in AGS form, and you can download AGS data from the BGS as well if you look at our Accessions database, or if you have your own AGS file, either from your archives or from a contractor, you can also bring that in. Again, you can go via the import menu, and there's an AGS specific import. We have support currently for AGS 3.1 and 4. Both of those should work, but for speed, I'm just going to just drag that file up into the user interface. Oh, it's stuck on the Windows folder. Classic live demo situation. Yeah, so that's now loaded in. So blink and you miss it, but that has just loaded in from drag and drop. And the boreholes will appear as folders. So you can see here I've got 44 boreholes in that particular file. It will show you a list of all of the borehole locations in the tree, and we can expand those to see what's in there. So we have attribution from the AGS file. We have geometry. So in the case of AGS, it will be easting, northing, and ground level, but we can actually bring, in theory, deviated boreholes in there, but in practice, we haven't really tested that. But you also get the geology log, which can be multi-attributed. So in this case, we get the legend, we get the description, but you don't have to use an AGS standard. You could actually just call these whatever you like. So you could call it lithology or stratigraphy or whatever. It's a flexible data model. And then under here, we have all of the data tables, which might be things like tests, in situ tests, laboratory tests, and other types of observations. So that all comes in. So there's an ISPT table here related to the data set. So all of this can come in. And in the current version of Groundhog, you can eyeball it in a sort of spreadsheet view, but you can also, depending on the data, we're slowly adding graphical features, which we'll see in a minute. So I can add that data set up into the map. It's now available as a layer because I've loaded it. And we can see the locations of that data. You can see Groundhog also graphically makes the distinction between boreholes and bore pits. And if we, just going to pick a log template, which I'll explain in a moment. But if I hold down the Shift key and hover over this location, I can see a little preview into that borehole. So I can do this across the whole project. And I can also right-click on a borehole location in the tree or in the map, and I can view borehole log. So that throws up this screen asking me to select a template. So within Groundhog, you can develop custom borehole log templates, and I'll cover that briefly. We've got quite a bit to cover here, and I don't want to take up too much time, but I'll show you the basics. So I've got it pre-cooked to use a template that I've called AGS, which will suit AGS. I think this is probably an AGS 4. Yes, it's an AGS 4 file. And I can remember that decision against a particular borehole or data set. And then it will display in a separate panel, it will display the borehole log report using the chosen template. So I can do that for any of these locations here, either from the map or the tree. Okay. And you can see that we have various column types. So we've got depth scales, which can work in feet or meters. We've got a kind of interval geology column, which can display colors and or ornaments. Depth marker columns, descriptions. Water strikes, if they're in the data. I'm not sure we'll have any in here. It looks like it's blank, actually. So you can have your sort of strike and rest levels in there. Information about what samples are in there. You can actually display sample values, depth, and things like the borehole installation column. I won't go massively into the detail of this. It's all in the user manual, but the idea is you can go into an edit mode and you can actually play around with this display. You can drag things around, reorder things, put them however you like, and you can add your own columns. So let's delete this description column and re-add it so you can see how that would work. So on any of these headers, I can just right click and insert a column on left or right. And then I get various column types, graphical types that I can use. So installation curve we use for maybe things like test data. I'll show that in a moment. Depth scales, geology logs, etc. Let's go for text. And then that will dig into the data model of the data set that we've brought in, and it will show me all the possible data tables. So again, for those of you familiar with AGS, I know there's a table called GEOL, which has got the geological descriptions inside, and then I drill down to the field within that table that I want. And then that adds the description field. We can also play around with these header fields. So these are all editable. I can either use free text into those header fields in the template, or I can have them be dynamic based on various attributes of the borehole. So I could put the easting in, for example. If I could type, that would be useful. And then just insert that dynamic field, and that will auto-populate for whichever borehole is being displayed. So you can see I'm pulling on a few values here, so some project level information, the project, the contractor, etc. And you can add as many rows into here as you like and so on. So you can insert columns and rows into here and build that up however you like, and you can add your own custom logo as well into there. Once you're happy with those edits, you can also change things like page setup. So I can change the number of units per page. So I could try and stick 10 meters per page in there. It starts to get a bit sort of cluttered, but obviously that will vary depending on what data you're displaying. And I can also change things like fonts if I really want to as well, and font size. I can save these out to a PDF. So I'm kind of laboring this screen a little bit because I'm kind of guessing that most people on the call will at some point have to deal with borehole data. So this is useful basics. Not sure where I saved that now, actually. Let's have a look. Oh yeah, there, log export. So that will go out as a PDF. I didn't set the page size correctly, so it's trimmed it off, but you can do a page size setting. So that lets you export your boreholes as a custom template into PDF, or you can just save them out as an image or send them to the printer, etc., etc. And once you've edited these templates, you can save them, and then they will become available across every session, or you can save them at the project level if you want them to be project specific. You can then share the templates with other people within your team or organization. So that gives you a little insight into boreholes. You can import boreholes. You don't have to have AGS data. You can import that from CSV, for example, or a text file. So I can pull in a collar file, for example, and then I get to map the key fields like the ID, easting and northing, the minimum set of fields, ground level if I've got it. And then I can pull in geology as well. Again, map those, make sure the ID matches across all of your tables so that it can match up the records. Top and base match to from and to, or you can also just do depth if you've just got curve data. Give it a name, and then that's come in just from a CSV file. So there's lots of different ways of getting stuff in, and your CSV data doesn't have to be geology. It can just be test data or something like geophysical data. So to demonstrate that, for anyone who's working with maybe some sort of wireline logs or something like that, I think I have an example. So I've got a LAS file here, log ASCII standard, sort of oil and gas standard here for things like gamma log. This is actually an example from the Kansas Geological Survey because they have a great archive of freely downloadable LAS data, which I just use for testing. But I'll just show this as an example. I've got one well in this file here, and then the curve data comes in as a spreadsheet with all of the test values. So depth, and then all of the different tests. And we can display that as well. If I can find a suitable Gamalog example template there. So you can display curve data as well, and you can play around with that. You can build templates up from scratch as well, so you can just create new templates. And let's pick on a different value in the so just maybe like porosity or something. Switch off the edit. Looks like that test is yeah, not too much data in there, but you get the idea. And then you can play around with appearance and things. So you could set it to be a different color. You can fill it and so on to get that appearing however you like. So that's kind of a whirlwind tour of boreholes. So hopefully gives you an idea that you can do a reasonable amount in Groundhog, and all of this is in the freely available version, just to be clear. So the next thing you might want to do is to draw a geological cross section. So we start by doing that in the map, and you can either connect up boreholes or not, depending whether you have them, whether you trust them, etc., etc. Groundhog's completely flexible. And the way to start drawing boreholes, again, because everything's layers based, is to add the cross-section layer to the map. So this is a single layer that's always present. At the moment, all of your cross-sections go into one folder. We're aware that's not necessarily ideal on some complex projects. So we're looking at ways we can have multiple cross-section folders. But for the moment, it's just one layer called cross-sections. When I first add that, nothing visually changes because I don't have any cross-sections in here yet. But the idea is that we then make this layer active so that we can start drawing into it. This is where we start to get into the digitizing tools within Groundhog. So any layer that you can digitize into will, when made active, it will throw up this drawing palette or tools palette, as we call it. In the case of a cross section, the only meaningful drawing tool is a polyline. So if I pick that tool up, I can just single click to place points and double click to finish, and that will give me a cross section. So I just give it a name, and then you can see that adds the cross section into the tree, and it then becomes part of this cross section layer, which can be toggled on and off. But for this demo, I'm going to try and join up some boreholes to see what's possible with that. So let's just start in an arbitrary location, add a couple of points. And then if I hover close to a borehole, you can see it does a preview of that borehole. That just confirms to me that it's going to snap to that location. So I can just do this, double click to finish, call it S2. And then when I've finished drawing into my cross sections, I just deactivate the layer. I can then, from the tree, right click and view the cross section, or I can do the same from the map as well. Just right click on the line and view. Nothing visually has happened here because I've got the map window maximized, but if I drag up this bar from the bottom to rearrange the user interface, you can see that something has appeared. Now, what I've attempted to do here is use quite a complex log template in quite a short cross section. So I'm going to try and change that a little bit. So currently I'm displaying my boreholes 1,000 meters wide, which is going to be very cluttered. So let's make them 10. So that's a little bit clearer. So what you see here, you're seeing a profile view of that cross section, and you get this layer called terrain profile. So Groundhog will auto sample a elevation model or a DTM. I won't go through in detail how to load your own DTMs. Groundhog comes pre-configured with an embedded 250 meter Ordnance Survey terrain DTM. but you can add your own. It's relatively simple to do. You just need an ASCII grid file, and you just drop it into your project and it will pick it up. And those objects appear under this reference grids. So you can see I'm actually working on lots and lots of different grids at the minute. So I'm actually running on a 50-meter DTM, but Groundhog will come with a 250-meter if you just download it. If you want help in getting your own DTM put into there, then just email us. So if I zoom in here, you can see that it's at each borehole location. It's displaying using this probably a bit too complex template for this example, but it gives you the idea. It will center the template on the borehole location along the section. And you can just switch out templates at different times. If you have different boreholes which have a preferred template and they differ, each borehole will show with its preferred template. So you can mix in, say, some geophysical logs with some geotechnical logs all within the same section and have them display with different templates. If you don't want to draw your cross-section all the way through all of your site boreholes, you can just sort of bash a line straight through. And let's open up that cross-section. So this will just present a blank section to begin with the profile, terrain profile. But you can actually buffer in or project, as we label it, by a fixed number of meters. So if I buffer by 100 meters, it will then bring all of those boreholes in. So you don't have to run your section through every borehole. So that's blending in sort of boreholes to cross sections. I'm going to come away from boreholes just for the moment so I can show you the drawing tools within the cross section. So I'll switch boreholes off and we'll just work into this cross section. So just ramp up the opacity on my terrain profile. When you create and open a cross section in Groundhog, you'll see this layer called geology, and again, everything in Groundhog is layers based in map and section window. If I make geology active, we get another drawing palette within the cross section view. So let's just maximize that a little. So we can just start drawing, but the idea is that we choose geology codes first, and we can do this in two ways. So I can either go to my drawing code library in the left-hand panel, and I can just pick, for example, made ground, or I can click either in the map window or the section window, this button here, which shows the currently active drawing code, and I can just change it for something else, say boulders. So pre-warning, I'm going to draw absolute nonsense in this example, but it's really just to show you the drawing tools. I'm not going to try and match this section up to the geology in this real location, but you can see that if you have the map and the section window arranged appropriately, when you move the mouse cursor in the cross section, it will show you what location of where you are as a crosshair in the map as well. So you can match up between the map and the section. So I'm going to switch back to my made ground code actually. And then I've got two tools. I've got Polyline and Pen Tool. I'm going to start with Polyline. So the idea is that you just start drawing a shape. Everything in Groundhog is the base of the deposit. Single click to place a node and double click to finish. And that just creates a line. What I can then do, so within the cross-section window of Groundhog, there's a polygon builder running in the background at all times. So if I make the line active, the lines go green, the nodes go green, and I can move them around. And if I drag the endmost nodes up to another line, it will start to snap. And once both ends are snapped, it will automatically create a polygon using the appropriate legend color and ornament. So I can leave the layer active and pick another drawing code. So let's say I'll go for clay. And I'm going to switch to the pen tool now. The pen tool is a bit more of a high-speed option. You just click and hold, and then just drag, and then you can just create line work like this and release once you're finished. Again, if you do that and you don't quite get the snap correct, you can just snap, and you can snap to various things. So here you can see I'm snapping to the edge of the section. It won't let you draw beyond that, or I can snap upwards to the terrain profile. If I've snapped something I don't want to, I can hold Control and pull it away to de-snap. So I'm just going to quickly sketch just a couple more layers into here, just keeping an eye on the time. So again, I'm drawing complete rubbish, but I'm just trying to show you some of the different types of polygon relationships you can build. If I double click slightly the wrong side of a line, it will auto snap. So you can see I can make these sorts of relationships. And once they're snapped together, they will move together. I can also, let's pick another layer. So let's say I pick chalk. As I move the mouse cursor around in the cross-section window, in the status bar, you can see it gives me readouts of W, which is like a chainage value along the section, and Z, so I can see what elevation I'm at. I'm just going to read off there -30, maybe -40 meters. So with the rock code selected, I can just right click and create a line. It says chalk, that's the active drawing code. And then I can do fixed elevation or depth. Go for fixed elevation and just type a number in meters, and that will just stick a layer in. So it gives you fairly rapid drawing and sketching tools. If I pick a sand, I can draw within a layer like this. So I can make a sort of lens, and then if I snap those together to make a polygon, it will do that. I can also, there's a special drawing code called Fault, which allows me to split lines. So if I put a fault line through here, it will prompt me to split the correlation lines, as we call them. And then if I zoom in, I can actually offset these lines and re-snap them to the fault. And deactivate the layer. So you get a few graphical settings on the geology layer, so you can change opacity, obviously, but you can also toggle on and off individual units. And you can switch on and off things like the ornament and the color fill, and you can switch on hard borders and things like that. So that's just a really quick demo of the drawing tools. These cross sections can get very complex. There's no real limit to how complicated these sections are within Groundhog. You can draw also at any scale. So if I put the topo map back on, just to prove that point, let's do a cross section right down like this. Let's take in all countries within Great Britain, and let's open that up. So again, it opens in this profile view. The terrain profile looks quite flat. That's because we're working at a particular scale, but I can change the vertical scale on there. Let's make it 20. And you can see it's picked up the topography. It does a rough estimate, but we can actually switch out resolutions on that. So I can go full resolution. That will take a moment to generate potentially, but you can work at high resolution on these profiles. So that gives you a bit of an idea of the basic cross-section drawing tools. What I'd like to do, I'm just mindful of time, just in the last couple of minutes, is just very quickly show you what we can do in terms of 3D geological modeling within Groundhog at the moment. So for this, I'm actually going to see if I can fire up a new copy of Groundhog. It's a clean sheet of paper. And I'm going to load a pre-existing project just for speed to show you what's possible. We did do a webinar on how to build 3D models using Groundhog, and these are features of the professional edition I should make mention of. So this is part of the commercial version that we're doing in collaboration with LQM. But when this fires up, I'll load up an existing project that we used as the basis of our webinar a few weeks ago, which you can re-watch on the YouTube channel for Groundhog to see how that was made. So let's just see. Let's load the project. So here's one I made earlier. So in this case, all of the geological 3D models within Groundhog are based on multiple layers. So you have a stratigraphic sequence within your model. So this here I'm working on, ignore the colors, they're not correct BGS colors, I apologize for that. But I'm working in an area of Northwest Norfolk where the chalk and things like the Carlstone outcrop. And you can see we've got a superficial till layer on top, and then a couple of other layers like the chalk layer, Carlstone, and the model base. All the layers are defined in sequence, and then every layer is basically generated as an elevation grid. So let's have a look at a slice through this. The inputs to these models can be boreholes, they can be structure contours, outcrop locations, dip and strike measurements, and so on. And then you can see this is a synthetic slice through the model. And let's have a look at the model editing. So to build a model within Groundhog Professional, we just define the model capping layer, as we call it, clipping layer, which is the DTM. Set a sort of model bounding box. It can be rectangular, or you can also draw a shape. Set the cell size or resolution. So let's pick something else. Let's do, just for speed, 200 meters. And then you add your layers, and each layer can have multiple inputs. So this West Melbury chalk, I've got an input of some borehole data, so base picks from boreholes, plus some outcrop locations that I've digitized. And then we can just apply and build the model. As you can see, the models calculate fairly rapidly, and let's see if we can have a look at that in 3D. Appreciate this is super whirlwind tour of the 3D modeling, but it's just to show you that exists as a thing within Groundhog. It's a little bit sort of beta at the moment, but we can build models into here. I'm working at a really coarse resolution, as I always do for demos, because it's to do with speed. If you ramp up the resolution of the model, it can slow things down. It takes a few minutes to build the model. So that's all that is. So it looks quite blocky, but that's just for speed. And then we can change the inputs. So I'm working on points for the West Melbury, and I can, let's say I just put some total nonsense over here. So these will be automatically assumed to be outcrop points. If I then rebuild the model, it will start to pull it around. So it's quite iterative and dynamic. And you can also have things like fixed inputs, like fixed dip and azimuth for layers, to rapidly just sort of bash them into the model. So that, I just wanted to show you that the 3D stuff very quickly. If anyone's more interested in seeing a bit of detail of that, just get in touch with us, and we can easily arrange a 30-day trial license and have a Zoom call with you to get you going with testing the modeling. Not quite sure who on this call is super interested in 3D modeling, so I just wanted to bring that up. And then obviously, if I draw a cross section through the model like this, I can then view a slice through that. So I get my standard view with the terrain profile, but again, because everything is a layer within Groundhog, I can add the model as a layer, and it will dynamically query that as a synthetic slice. Obviously, it's not matching the terrain very well because we're working at a very low resolution. So yeah, I'm always amazed in these demos how quickly time goes. So we're at 52 minutes past. So I guess it's probably time for me to drop out and maybe take some questions. I'm not sure. I can't see you still on the call. So if Mike, are you still there?
I am. There's about 38 of us listening intently. So
yeah.
That was really good, Ben. I have to admit, I've heard bits and that of it before, and it's always impressed me. So I thought it was a brilliant opportunity for you to tell a wider audience about the sort of capabilities of Groundhog, and certainly what you can do for absolutely free. And particularly impressed at the way you can then load in from our databases, not only the geological maps, but loads of boreholes, AGS data. It's a really useful way of getting into the BGS free data.
Yeah, definitely. So yeah, I mean, thanks for the opportunity, Mike, and thanks everyone for being patient and watching through. One of the areas we are expanding into is to make Groundhog more of a vehicle for BGS datasets. So we've just sort of done the tip of the iceberg on that at the minute. We've got a lot more that we want to do on that, but it was just to give you a flavour.
Right. Well, let me remind you, if you've got any questions for Ben, then the Zoom chat is the easiest one. Just put the question in. Or I think you should have somewhere a hand. If you go to, I think maybe reactions. No, that's somewhere there should be an opportunity for raising a hand, which I can see on the list of participants. But
it's on the participant list.
If anybody's got a question, the easiest thing is just unmute yourself now and ask away. So at the moment, there's a call for questions, but no questions coming in. If I can start, I mean, I know this is, as you said, a lot of work and kind of followed on from the GSI 3D that BGS was heavily involved in. How many people have been working on Groundhog, and how long has it taken you to get to the level you're at the moment?
Yeah, so thanks, Mike. It's actually the project's been going for about 6 or 7 years now, actually. And it started out life as a simple tool for visualizing corporate databases within BGS. So within BGS, we have a few extra tools for connecting through to our borehole databases and so on. And it kind of existed in that form for quite a long time before we decided to try and push it out for people to use. We're a very small team, relatively speaking, compared to other people trying to put geological software out. There's always less than half a dozen of us as a combination of software developers. So there's sort of four on the core development team at the moment, and there are various other key people around the team who help us, who are more on the geological side or the data side, who are helping us to try and make it fit for purpose and test it and apply it to projects within BGS and beyond. So we're kind of sort of 6 or 7 people on and off, depending on what we're working on at that particular point. So yeah, relatively small team. We've done a few different things over the years and tried a few different applications for Groundhog. As I said, the initial application for the first few years was internally focused, but we've since pushed it in the direction of external applications. We're particularly interested in whether we can push it forward as a tool for kind of site investigation, because we see a bit of a gap there, and trying to get people enabled with 3D modeling tools with an integrated environment for bringing all their SI data and GI data in, and potentially building 3D models using a relatively simple tool. So that's kind of where we're going at the moment with LQM as well as a collaborator.
Can I ask, as I'm still keeping an eye on the chat and no other questions in yet, of the people who use it, do you have any idea how many are sort of serious users, perhaps using it professionally, but on the community version rather than the professional version, and how many maybe academics or students who use it as a way to view boreholes and for as part of a teaching learning experience?
Yeah, at the moment we don't have hard figures on that. We're trying to get a bit more serious about sort of gathering metrics about who's actually using it. So far in recent years, we've just kind of put it out there, but in the last year or so, we've tried to get more serious about engaging with people. We have an ongoing relationship with the hydrogeology MSc at Newcastle University, where we're using that as a test bed for embedding Groundhog within actual teaching modules, and that's working quite well. But the best sort of barometer of who's having a look at it and who's using it is we have a help desk email, which is groundhog@bgs.ac.uk, which gets regular emails from all sorts of different people from around the world. So we're currently running at something like 1,300 downloads a year or something like that, and that's from every sector you can imagine, academia, individual researchers, and hobbyists, through to the sort of the big engineering firms. We also have really close links with other geological surveys. So we currently have two really key collaborations with Sweden and Finland geological surveys, where we're actually working with them to build up the 3D geological modeling capability. And the direction we're going there is to give them tools for more rapid regional scale quaternary modeling, because that's currently quite difficult to do with the commercial tools that are available. So it's a bit of a mix at the moment, but as I say, we're trying to, in terms of the functionality of the software, we're interested in shallow geology, quaternary modeling, so those tools for 3D modeling, which is where we came from with GSI3D back in the day as well. But so we're not so much interested in the deep bedrock, because that's well served by a lot of the commercial applications, things like Skewer GoCAD or Leapfrog, etc. And applications like Micromine that come from things like mining, oil and gas. So we're more interested in potential engineering and environmental applications, shallow geology, but at the minute we've got a real broad mix of people downloading using the software, and actually quite a lot of interest from students, which is I think going to be really important for us as well, to get people on board while they study as well.
Great. We have a question coming in from Samuel Lawrence. Samuel, could you unmute yourself and ask your question, please?
Hello. Yeah, I utterly failed at locating the raise hand button. Hi, Ben. Thanks for the presentation. I think there's really great promise in this, and I've bookmarked a couple of YouTube videos already. My first question is, in terms of the borehole logs and indeed the cross sections, is there the ability to add downhole imagery from a geophysical survey?
Great question. It's something we've come up against before, but we haven't solved it yet. So the short answer is no. But we are working with a team. Actually, it's related to stuff that Mike does. We've got the core scanning equipment at BGS, and we're working with a little team there to see if we can get some of that core scan imagery in, registered with depth. So at the minute, no, you can't really do it. You could actually, technically you could, if you pretended the images were ornaments on your geology intervals. So if you want to have a go with that, get in touch with us and we'll see what we can do, but not really. So that will come in a future version, probably not the next version, which is due out around a month's time, possibly a version or two after that. It's definitely on our to-do list.
I'm glad that's on your roadmap, and some of the other, should we say, more established players don't seem to be interested in adding that to their packages.
Right.
So I think it's really useful. And my other question, I'm sure will be answered by the YouTube videos, but the looking at the 3D models that you were showing on screen, you've taken a bit of a block modeling approach to rendering those 3D models from the get-go. So as an ambition, do you think you're going to move on to trying to add things like inverse distance or kriging in more of the sort of block modeling aspect that you see in your Serpax and Micromine? Is that a far off aspiration?
Yeah, so do you mean sort of like interpolation of properties within deposits?
Yeah. So, for example,
kind of thing,
estimating gold grade or sulfur trioxide concentrations in limestone.
Yeah, that's a tricky one for us. I mean, it's kind of on our wish list, if you like, but again, it's about us talking to industry and figuring out how useful that is, because obviously we're aware that if you come in, say, from a mining situation, that's, you know, it's a given. You're going to want to have to do that. But we don't really necessarily want to replicate what you can already do in some of those mining packages, because it might be better for us to build functions elsewhere that don't exist, for example. So at the moment, we're not entirely sure. I guess we're at the stage of gathering use cases for the modeling. The first step is just to get that basic framework structural modeling done. And that actually uses, so the idea with that is that you'll be able to choose your algorithm for building the deposit layers. At the minute, it's using a natural neighbor, but we will be adding options for radial basis function and basic kriging with a spherical system. But in terms of actual 3D interpolation, we're not taking that too seriously at the minute in terms of the next year or so, because we just want to get those basics done. And we know that if you need to do that, there are packages that do that brilliantly already, so it might not be the best use of our time. But
yeah,
if you're interested to send us some examples or use cases, that would be really useful though.
It might be something for us to I'd be happy to discuss it with you moving forward. I personally use block modeling, but for in terms of quality in quarrying for cement manufacture.
Right.
I think that because quality constraints in a lot of industries are getting more and more getting tighter, it's not just your base and precious metals companies who are concerned about it now. I think there's more of us starting to pay attention, but it's not what I came into the webinar looking for, but just the way that you rendered the 3D models.
Yeah,
it looked a bit block modeling, so I was interested
to know what were. And we do have a data model that would support it. We just don't have any interpolators at the moment. So yeah, it's possible.
Okay, thanks very much.
Thanks.
Thank you. Some good questions. We've time for one or two more questions. If there's anybody, I haven't seen any raised hands, but if there's anybody, feel free to unmute yourself or put something in the chat. If I can just ask yet another one, sorry for hogging the floor, but my prerogative as chair. BGS has a number of things like dig to save, where we're trying to work with companies, just as we make AGS data available. If they've got suites of boreholes, they can then deposit them with us on the basis that it doesn't really cost them anything, and it may well help them and other companies in the future. So in other words, if they contribute now, then it's a resource which will help them in the future. Is there any way, if somebody is using Groundhog and they've obviously downloaded existing stuff and then they add a whole load of their own, is there any simple way they can then offer that as an export back to BGS?
Yep. So all you need to do for that, so we've been working with a guy called Steve Thorpe from the BGS, who some of you may know. So he's got a project which he's actually kind of relabeled the Big Borehole Dig. The idea behind that is that people could code up boreholes and submit them to BGS for everyone to see, as you said, Mike. And we're working with Steve on using Groundhog as an option for that. So you can currently do that from within particular versions of Holebase, from Kinetics as well as now from Bentley. You can also do it from within Groundhog by basically code up the boreholes within Groundhog. And I didn't actually show the editing functions, but you can edit borehole logs within Groundhog and just export as an AGS file. And then take that AGS file and upload it to the BGS ingestion portal. And it will filter through. So I think Steve Thorpe has produced a document on the workflow for that. So if anyone's interested, again, perhaps just drop an email to the groundhog@bgs.ac.uk and we'll hook you up with that guidance document. But you can definitely do it. At the moment, it's a mildly long-winded process, and we're working with Steve to streamline that we might be able to enable a direct upload to the BGS system from within the software. But at the minute, you'd have to kind of export as AGS and then drop that AGS into the BGS website. But it does filter through.
Great, thanks very much. Well, I think as time is pressing on and there's no more questions, I would like to thank you, Ben, for a very interesting hour. I've seen Groundhog, well, I've done a course, I have to admit, but I found it a really good way of bringing a whole load of BGS data and other data together to help you visualize what's going on in an area. Now, I'm, of course, I'm a curator, so for me, it's more like bringing in where we've got borehole core, perhaps logs of boreholes that we don't have things from, helping you to visualize it, see how it sits with the geology. So I know I'm an unusual case like that. And obviously, if you're involved in site investigations and things, it's much more bread and butter. But I think it's a really interesting demo. Thank you very much indeed. And as I say, any questions or anything, then Ben is the contact, or I forget, was it Groundhog? There's
yeah, just groundhog@bgs.ac.uk is the best way, because quite a few of us look at that inbox, so we'll be able to respond more
Right.
quickly. But yeah, thanks for the opportunity, Mike, and thank you everybody for your time.
Right. Thanks very much. And one final parting comment. The next meeting we have scheduled is our Christmas meeting that will start at the same time, 5 o'clock on Tuesday, the 1st of December. And we have a minerals evening for you by Roy Starkey, who has written the book, The Minerals of the, I think it's the English Midlands. It will be very much a sort of pretty picture evening. We'll send out the flyers in due course, but we normally, of course, at Christmas have mince pies and mulled wine. So I think what we might do is ask you to bring along with you for your Zoom meeting your own mulled wine or other tipple and mince pie or something. And we might well have a bit of an informal chat either before or perhaps afterwards, probably afterwards. But I have heard Roy talk on a number of occasions, and he is a very good speaker, and he's a really brilliant photographer. So for a Feast of Minerals, it should be absolutely first rate. And of course, it's aimed to be not just for, let's say, hardcore geologists, but open to families as well. So if you've got friends, well, if you've got people in your home bubble or whatever who are interested in seeing really attractive pictures of minerals, then it should be a much freer, open evening for everybody. So 1st of December, Tuesday, starting at 5, but we'll follow up with more information. Okay, many thanks to everyone. Thanks, Ben, again, and thank you all for attending. Right, bye.
Thank you.
Okay, thanks, everyone.